Download this code from codegive.com, link in the description below. Creating a simple API rate limiter with node.js and redis. This tutorial demonstrates how to build a robust API rate limiter using node.js and redis. We'll focus on a simple, yet effective, implementation that leverages redis as data structures for efficient storage and retrieval of rate limit information. This approach scales well compared to in-memory solutions, especially under heavy load. Why redis? Redis is an in-memory data structure store, making it incredibly fast for read and write operations. Its support for various data structures like hashes and sorted sets makes it ideal for implementing rate-limiting strategies. We'll use redis as increased and expire commands to manage request counts and timeouts. Prerequisites * node.js and npm, or yarn. Make sure you have node.js and npm, or yarn, installed on your system. Redis * you need a Redis server running. You can download and install it from the official Redis website, https://redis.io/ https://redis.io. Express * a node.js web framework for building the API. Redis * a node.js client for interacting with the Redis server. Installation * code implementation * explanation * 1 Redis connection * the code establishes a connection to your Redis server using the Redis client. Make sure to replace redis / localhost 6379 with your actual Redis connection string if it's different. 2 Rate limiting middleware, rate limiter. This middleware function handles the rate limiting logic. It extracts the client's IP address. You could use other identifiers like user IDs for more granular control. It constructs a Redis key using the IP address. This key uniquely identifies the rate limit for each client. It retrieves the current request count from Redis using redis client.get key. If the key doesn't exist, parseInt current count handles the case gracefully by defaulting to 0. It checks if the request count exceeds the request's allowed limit. If so, it returns a 429 too many requests response. If the limit isn't exceeded, it increments the counter using redis client.increased key. It sets the expiry time for the key using redis client.expire key time window ms/1000. This ensures that the counter resets after the specified time window ms. Finally, it calls next to proceed to the next middleware or root handler. 3 Protected API endpoint /API/data. This is a sample API endpoint protected by the rate limiter middleware. Any request to this endpoint will be subject to rate limiting. 4 Error handling * the try catch block handles potential errors during Redis operations. Running the application * 1 Save the code as a file, example server.js. 2 Run the Redis server. 3 Run the node.js server, node server.js. 4 Test the API endpoint using a tool like curl or Postman. Make multiple requests within the time window to see the rate limiting in action. Improvements and extensions *. More sophisticated algorithms * explore more advanced rate limiting algorithms like token bucket or leaky bucket for finer control. Different rate limits per user * instead of IP addresses, use user IDs for per user rate limiting. This requires authentication and authorization in your application. Sliding window * implement a sliding window algorithm for more accurate rate limiting over a specific time period. This would involve more complex logic within your rate limiter function to account for requests falling outside the defined window. Distributed rate limiting * for highly distributed systems, consider using a distributed cache like Redis cluster for scalability. Customizable rate limits allow configuration of the request's load and time window ms values, either through environment variables or a configuration file. This detailed tutorial provides a solid foundation for building API rate limiting into your node.js applications. Remember to adapt and extend this basic implementation to meet the specific needs and complexity of your project. Always prioritize security and consider the trade-offs between performance and accuracy when choosing a rate limiting strategy.